everyone. So today we will discuss stereochemistry, and in that we will discuss mirror images, how to find whether images are superimposable or non-superimposable. So this is a good trick. This is how you can find on rotation. You have to check superimposability or non-superimposability. So let us start. So here we have this molecule, and this is our chiral center, chiral carbon. We have 4 carbons. Out of these 4 carbons, because carbon number 1 has 3 similar atoms, so it is not chiral. Carbon number 4 also has similar atoms, 3 similar atoms, it is not chiral. Again, same situation with third carbon also, it has 2 similar atoms, it is not chiral. So these are not chiral, but carbon number 2 have 4 different valences. It has 4 different atoms on on 4 bonds, so it is chiral carbon. So our main focus will be the spatial arrangement around carbon number 2 only. So let us start. So if we draw its mirror image, it will be like this. So these are the bonds. This green bond is below the plane. This bond is above the plane, pointing toward you. Similarly, here this bond is above the plane. It is pointing toward you, whereas it is pointing away from you. So this is below the plane. Right? So if we'll draw its mirror image, it will look like this. So our chiral center is this one. This is our chiral center. So we'll consider the stereochemistry around this only. So this ethyl group will be closer to the mirror surface, and then this methyl will be farther from it. Okay. So as we have property of mirrors, that the distance of an object from the mirror and the distance of image from the mirror will be equal. Okay. From here we concluded that the bond which is present in its object, object image, if it is below the plane, it will remain below the plane only. It is here in below the plane only. But if a bond is present above the plane, it will be above the plane. But what is the change here? The right-handed group has shifted to left hand side, and left hand sided group has been shifted toward right hand side. Okay, so like we have methyl group here, it has been shifted toward right hand side with respect to the chiral center. So अब हम इसको अप्लाई करेंगे 3D इमेज में, समझने की कोशिश करेंगे. So I have to just rotate this molecule in order to have such orientation, and then we'll check whether we are getting similar image or different image. Okay, similar molecule. So actually we are shifting these molecules, this and this molecule, ethyl and methyl molecule. So I have to just rotate it around this axis. I have to rotate this molecule around this axis, and angle of rotation is 180 degree. How do you know? Because this line where I am drawing this line, we have to shift these 2 molecules, methyl and ethyl group. Okay, so I have to shift the right hand sided molecule toward left and left hand sided molecule toward right. So means angle between these 2 is 180 degree. So rotation is of 180 degree. So let us start. So here I have this molecule, same orientation. The green ball is below the plane, and white ball on the chiral center is above the plane. Hydrogen is above the plane, chlorine is below the plane. This is an example of 2-chlorobutane. So methyl group is on left hand side, ethyl is on right hand side. So let us rotate this molecule now. We have to shift these 2 positions only, So angle is of 180 degree. When we will rotate it, it will be of 180 degree. So upon rotation, we are getting such type of orientation. So from here you can see that you have shifted the 2 positions. Now your ethyl group is closer to the mirror surface, whereas methyl is away from the mirror surface. But what about the remaining groups on the chiral carbon, hydrogen and chlorine? What is happening with them? It has been above the plane. This green ball is pointing toward you. It is pointing toward you, whereas this hydrogen is below below the plane. It is pointing away from you. It is not toward you. If it is toward you, then the arrangement will be different. Right, left-handed group is methyl and right-handed is ethyl. So what is happening on rotation, on exchanging the position of ethyl and methyl? The position of chlorine and hydrogen has also been changed, So now your chlorine is above the plane. This is above the plane and hydrogen is below the plane. So such type of orientation we are getting. So this was our original molecule. We have shifted methyl and ethyl group. We have exchanged these two positions. So on exchange, what is happening? These two positions are also exchanging. So now we are getting such orientation. Now your chlorine is above the plane and your hydrogen is pointing away from you. That is, it is below the plane. No doubt, now your ethyl is present on left hand side and methyl is present on right hand side. No doubt in that. So if we are considering these two molecules, these are mirror images. Let us check them out. इनको हम चेक कर लेते हैं. तो यहाँ पर देखिए, these groups are okay. मिथाइल की पोजीशन पे when it is mirror image, methyl will shift toward right hand side and ethyl which was present initially on right hand side, left hand side में आ जाएगा. But the position of these two molecules, these two atoms also has been shifted. Hydrogen, it is previously was above, whereas it was below. But now on rotation we are getting them in reverse directions. Chlorine is above the plane and this hydrogen is below the plane. So these two are not the same situation. These are not the mirror image. These are different molecule. If it is molecule number 1, it is molecule number 2. So if on rotation of this molecule, this number 1 molecule, if you are rotating it and then you have to match this image with the image that you have drawn here. So in its image, this chlorine molecule must be below the plane. But what is happening there on rotation? This chlorine has become above the plane. If this is the situation, then you will declare the images are non-superimposable mirror images. We are not getting it on rotation even. So these are non-superimposable mirror images. So this was all about. Thank you so much. Do like and subscribe my channel. Thank you so much.